Hello. I'm going to talk about consciousness. So I'm just going to dive right into it and say that I'll be offering the hypothesis that consciousness is an intrinsic property of magnetic fields, as well that the consciousness that we experience arises as a result of the interaction between the magnetic fields in our brain and the electrical activity happening there. Looking at it this way redefines the mind-body problem, as well as shedding light on the local versus non-local consciousness question. Most scientists these days feel that consciousness, although they don't know how it happens, arises as a result of processes or a process that happens in the human brain. This is a pretty reasonable proposition when you stop to consider that all of the consciousness that we've ever experienced, even inferring it, even making the inference that what we experience in consciousness is also present in other people and other species, all the consciousness that we know anything about has always arisen in association with living things. All the consciousness that we've ever experienced has arisen in conjunction with living things. It's hard to avoid the assumption that my next door neighbor is conscious, their cat is conscious, but that a rock is somehow not conscious. And this seems quite reasonable because the cat needs to survive, their owner needs to survive, and consciousness, like everything else that happens in our brain, ultimately arose from the evolution of our brain, the direction of which has always been to help us survive. The idea that consciousness is an intrinsic property of magnetic fields implies that even a single, simple magnet, like the kind that holds a recipe on a refrigerator, is somehow possessed of a rudimentary consciousness. By themselves, magnetic fields don't do very much. In order to get a magnetic field to produce electricity, you need to move the magnetic field, and you need to move it around a copper wire. That will generate a current. In the same way, the consciousness in our brains, the magnetic fields in our brains, are continually interacting with other magnetic fields, most especially, because of its constancy, the magnetic field of the Earth itself. There is no such thing as a magnetic field that exists in isolation on this Earth. The word consciousness itself presents us with a dilemma. I define it, for this video, as the capacity for subjective awareness. The problem is, subjective means about the same thing as the word conscious, and the word experience implies some kind of subjectivity in order to undergo and be aware of the experience. All definitions for the word consciousness, when it refers to subjective experience, are always tautological, so that one word means largely the same as the other. So if you define the first word using the second, you haven't said anything at all. The second problem with consciousness is that it's an inherently subjective phenomenon. It's not possible to demonstrate consciousness objectively. And subjective experience is never admissible as scientific evidence. So in order to prove that the phenomenon that we're discussing even exists, we must somehow step outside of the normal rules for science. And the normal rules of science are very strict about definitions for scientific terms. If a word doesn't have a meaning defined in terms of other scientific facts, observations, measurements, entities, categories, then we don't really have a scientific definition for the word, so we don't really know what we're talking about. Now, the way to escape this conundrum that I found that works in this case is to make an assumption or offer an axiom or a postulate, and that is that the experience of subjectivity reported by nearly all human beings exists in all human beings and has the same basis in all of them. Further, we can extend this assumption, this axiom, by saying that other species are also conscious and that their consciousness has the same basis that ours does. This allows us to think of consciousness, a subjective phenomena, as an objective phenomena, found in all human minds, found in all species that respond to stimuli. That, by the way, is a medical definition for consciousness, the capacity to respond to stimuli. And it really won't do when we're strictly speaking about subjectivity itself. There's more to subjectivity than simply responding to our perceptions. The brain works through a number of different systems, including an electrical system, a chemical system, and the system comprised of the very many types of tissue found in the brain, each one of which has a slightly different function or contribution to overall brain processes. What isn't as well known is that the brain appears to have a magnetic system. In fact, there are 5 million magnetite crystals per gram in the human brain, and the average human brain has about 1,400 grams. These magnets are very, very small. They have a shape that's unique. It isn't found in nature. It's only found in biological tissues. They're organized in long chains called magnetosomes, and in the human brain, a typical chain of magnets making one, I'll say it again a little more clearly for you, magnetosome, has about 50 to 100 magnets. The fact that they have shapes that are not found in nature but are only found in brain tissue is very significant, because it means that they were formed in the brain. They were formed while our brains were growing. And for all we know, they may continue to form well after birth. This is very well established science. There's practically no one left who feels that magnetic fields can have no effect on the brain. And there are very few people left who believe that fish and birds navigate by any other means than by following the Earth's magnetic field, using the magnetites in their brains. Dr. Kirschvink has suggested a mechanism where magnetic fields might influence brain tissues as well as its electrical activity. I'll paraphrase here because this is a YouTube video, not a Harvard lecture. A simple calculation shows that magnetosomes moving in response to magnetic fields about the same strength as those of the Earth are capable of opening channels between cells. The presence of trace levels of magnetite in virtually all human systems suggests that similar processes may explain a wide variety of weak magnetic field effects, both in the brain and throughout our bodies, as is described by some classical physics equations called Maxwell's equations that describe the relationship between electrical currents and magnetic fields. Electrical currents running through the brain along the axons, sort of like wires attached to brain cells, will induce movement in nearby chains of magnetic crystals. This will disseminate or spread the firing patterns in those neurons all throughout the brain. It's important to understand that magnetic fields never drop to zero. They get weaker and weaker the farther you go from the magnetic field source, but they never actually acquire a strength of zero, which means that every single electrical current in the brain generates a magnetic field that is spread through the entire brain. I've seen people fail to understand this point a few times, but the transference of information from one magnetic field to another magnetic field does not always rely on current induction, as we'll see in a few rather crude animations coming along later on in this video. If one magnetic field is being created with a pulsing pattern when pulses run down an axon, one of the brain's tiny internal wires, the same pattern of pulsations will also be imposed on all the magnets and the magnetic fields nearby. It's called a field-to-field effect. It's a fact of physics that a group of magnets don't make a group of magnetic fields. Together, they make a single field. That's how the millions of magnets scattered throughout the brain can combine to make a single consciousness. When current flows through a wire, it creates magnetic fields that surround it. This also happens when electricity is pulsed through a wire. This remains true whether these pulses get stronger or weaker, or whether they move faster or slower. The brain's magnetic field picks up all its electrical patterns, no matter what their volume or tempo, or in the language of science, their amplitudes or frequencies. Axons coming from brain cells behave very much like electric wires, carrying current and creating magnetic fields as they go along. When the electrical activity running down the axon is irregular, consisting of bursts or pulses, then the magnetic fields around it will also display bursts or pulses of magnetic activity. Here's a group of magnets surrounded by their magnetic fields. The purple dot represents the end view of an electric wire. We turn on some current, sending it through the wire, and we see that the wire's magnetic field begins to deflect and interact with the magnetic fields from the magnets around it. In this way, electrical activity in our brain, deriving from our thoughts, our emotions, our sensations, and anything else that's happening, is picked up by the magnetic fields that surround it. And in this way, the activity of our brains is imposed on our consciousness. In the lower right-hand corner, you can see a black bar rising up and down, showing you the kind of signal this might create. And here we find similar signals being displayed on an electroencephalogram, an EEG. The information it displays means nothing unless you've been trained to interpret EEGs. Here's an illustration many of you will have seen before. It's a fairly common image in neuroscience. It shows current flowing into a brain cell from several different sources. And here we've added a group of magnets, together with their magnetic fields. In this case, you can also see that the magnets themselves seem to be vibrating in response to the fields that surround the current traveling down the axons that connect brain cells to each other. In fact, the magnets, arranged in chains called magnetosomes, do move slightly in response to low-strength magnetic fields, although here we've exaggerated the motion to make it clear. A leading researcher in this field, Dr. Joseph Kirschvink of the University of California, tells us that a simple calculation shows that these magnets move in response to magnetic fields as weak as the ones from even the Earth's own field. And that's very weak. This is more than enough for them to respond to the nearby electrical currents within the brain. To put it simply, this is the interface, the point of connection between consciousness and matter. Consciousness is an intrinsic property of magnetic fields, and the things we perceive, including our thoughts and emotions, as well as the input from our senses, enter our consciousness, carried by the electrical activity from within our brains and from our bodies. The unity of magnetic fields and electrical current is the foundation for the unity of mind and matter. These processes happen much more quickly than what you've just seen. Even though not everything that happens in our consciousness enters our awareness, there's nothing that happens too fast for consciousness to pick it up. So what I'm suggesting is that consciousness is a property of the brain's magnetic field, and the functions that are associated with whatever areas have the peak magnetic field strength, or the most important information embedded in those fields, is what will determine the present content of consciousness. That is to say, what we experience now. And of course, I mean the recurring now of the present moment. One of the main characteristics of consciousness is that it permits the subject-object relationship, the perceiver and the perceived. And in order for that to happen, there has to be a thing called a feedback loop. Information fed into the system, ultimately deriving from our senses, is fed into the brain, where it creates certain electrical firing patterns. Those are picked up by magnetic fields, but then in order to respond to the sensation, those same magnetic fields have to feed information back again. And the two poles of a magnetic field, the positive and negative poles, correspond very nicely to the structure, the A-B structure of a simple feedback loop. Even though the two poles of a magnetic field, in interaction with any other magnetic field source, allow a simple feedback mechanism to appear, a feedback loop to appear, and this can form the basis of a rudimentary consciousness. In point of fact, such a thing would never happen in the brain. First of all, because the brain has 5 million magnetites per gram, and I believe that comes to something like 50,000 magnetosomal chains per gram. But this entire system is also continually acting and for much of our day moving within the Earth's magnetic field, so that a simple feedback mechanism is actually a very unlikely thing in the human brain. Very complicated magnetic fields produced by large numbers of magnetosomes would be capable of transmitting huge amounts of information. And the more complicated the magnetic system, the more information it could bear. There have actually been attempts to do a rigorous analysis of magnetosomes in the brain, and one of the authors of one of these studies has concluded that in fact the magnetosome magnetite system in the brain is actually capable of storing information, not just transmitting it, but actually storing it, which goes a long way to establishing the magnetic basis for consciousness. Human consciousness, as well as the consciousness of any vertebrate species, is characterized by its ability to perceive and respond to information from many, many different sources. In being a little rigorous here, we can say to perceive qualia and phenomes from many different sources. Phenome is the root for the word phenomena. So, for example, when we feel something from our bodies, we would expect there to be more magnetic activity in areas that are involved in the perception and control of our bodies, such as the cerebellum, the parietal strip, and a number of other areas, the basal ganglia, for example. And these create corresponding fluctuations in the magnetic activity in all of the areas that this information goes to. In fact, there was one study done where simple electrical pulses delivered to a finger actually created magnetic pulses which could be read coming from the brain outside the scalp. That work is actually kind of old, even classic. I believe it was done in 1976. Even though this kind of activity is spread all over the brain, it still unifies into a single experience, the conscious experience of the present moment, because a group of magnets does not make a group of magnetic fields. Rather, each one contributes to a single magnetic field, and whatever's happening anywhere in it is part of our conscious experience now. We don't experience everything with equal intensity because not all the information embedded in these magnetic fields is equally important. We can be aware, for example, of what we're watching on television at the same time as we listen to sounds coming from the other room and wonder what the kids are doing. And we can do that while we're waiting for the doorbell to ring because we're expecting a delivery from UPS. And we can do that while we also are aware of the sound of the wind going on outside the room and what that has to say about the weather. So even though we have a single conscious experience, it's capable of encompassing a wide range of subjective impressions and qualia and phenomes. So a single consciousness does not mean only one perception happening at a time. And besides all of this, our consciousness is also managing, in addition to all of its perceptions in any given moment, it's also managing our state of consciousness. So not only what we're perceiving and even our perception of our own thoughts, but what kind of mood we're in when we're doing it. The state of consciousness that we fall into when we suddenly become aware that there's a man-eating tiger a few feet from us will preclude our paying attention to many of the percepts that are available to us. We focus on what we have to do in that moment, and we can exclude a great deal. So state of consciousness, which in our use of the word is a bit of a misnomer. Remember, we're talking about the capacity for subjective experience. Magnetic information coming from one of our senses on an emergency basis would be, in principle, capable of organizing the entire brain's activity, including the magnetic fields that fill it, arising from magnetic fields all through it, and participating simultaneously, even though those magnets may be located in areas of the brain with very, very different functions. Some years ago, I published a paper called The Production of Consciousness Out of States of Consciousness. And in that paper, I pointed out that magnetic information can travel through the brain faster than information carried by any other means. Magnetic fields move through the brain at a significant fraction of the speed of light, and chemical reactions are a great deal slower. Magnetic fields also move faster than the transmission of electrical pulses through axons. It's hugely faster than the transmission of chemicals across synaptic gaps. So magnetic information offers the fastest means for one part of the brain to communicate with another part of the brain, or, for that matter, to communicate with the entire rest of the brain at once. Some years ago, I published a paper called The Production of Consciousness Out of States of Consciousness. And in that paper, I pointed out that magnetic information can travel through the brain faster than information carried by any other means. Magnetic fields move through the brain at a significant fraction of the speed of light, and chemical reactions are a great deal slower. Magnetic fields also move faster than the transmission of electrical pulses through axons. It's hugely faster than the transmission of chemicals across synaptic gaps. So magnetic information offers the fastest means for one part of the brain to communicate with another part of the brain, or, for that matter, to communicate with the entire rest of the brain at once. There aren't many circumstances where it really makes a difference whether information gets across your brain at 3/4 the speed of light as opposed to half the speed of light. But you can be sure that over time, over evolutionary history, those species that managed to have faster communication within their brains probably succeeded at the expense of those that didn't. If you need to respond to the fact that you see a man-eating tiger and you need to do it quickly, then that fraction of a second can make an enormous difference. In one case, if your brain is able to transmit information very quickly, you survive and somebody else gets eaten. If you've got the brain that doesn't use magnetic signals, not that there is any such thing that we know of, then you will be the one that doesn't survive. So over time, it's probably safe to say that nearly all vertebrate and especially mammalian species have used the same mechanism as the basis for their consciousness, because any species that managed to find a different mechanism, one that did not rely on magnetic signaling, would probably have been defeated in the great struggle of evolution by those that did. There are a lot of different phenomena and processes that happen within the human mind that are referred to as consciousness. One of them is the sense of self. And I believe that the sense of self is not constantly present. There is reason to believe that it isn't there when we're in dreamless sleep. It's there when we're asleep and we're having a dream. It's there when we're awake. But the human sense of self, indeed the sense of self of any organism in any species, doesn't appear to be an absolutely constant thing. And what we call self-awareness, being able to perceive what we are doing or thinking or feeling in any given moment, is not the same thing as the phenomena of awareness itself. The mechanism for being aware of ourselves is not the same thing as the construct of the self happening within the brain. So the sense of self is what happens when the areas of the brain that support the self are connected to the mechanism of conscious awareness. So when the areas of the brain that support the sense of self are receiving input, magnetic input from the rest of the brain, or producing output, magnetic output, that is spread to the rest of the brain, then we have what we call self-awareness. But self-awareness is not the same thing as awareness itself. So, for example, there are simple bacteria that navigate using chains of magnetosomes. These help the bacteria find the bottom in a pool of water they inhabit so that they can get closer to their food source. It's as though they have a consciousness with only one sensory organ about which way is up, which way is down, or alternately, which way is north and which way is south. So such a simple organism would have an awareness so rudimentary that we can't imagine what it's like to be such a creature, but it won't have a sense of self. It doesn't need one. It only needs to automatically respond to the pull of the Earth's magnetic field, helping it find its food source in very much the same way as a plant responds to the pull of the sun's rays and turns its leaves towards it, phototropism. So not every instance of consciousness is accompanied by a sense of self. There are some people, including His Holiness the Dalai Lama, who believe that consciousness is an emergent property of brain activity. That is to say that the whole of the activity that happens in the brain, electrical, chemical, and whatever else, combine and produce a circumstance in which consciousness emerges. The doctrine has been called emergentism, and I think it's good for me to take a moment to point out that I'm not an emergentist, and I'm not offering an hypothesis, a variation on emergentism here. What I'm saying is that consciousness is an intrinsic feature of magnetic fields. Consciousness is directly attributable to the magnetic fields in the human brain. And for those of you who are wondering what I mean by intrinsic in this case, I would point out that the same word is used when we say that gravitational fields are an intrinsic feature of matter or energy. Wherever there is matter or energy, which can be called mass, we will automatically find gravitational fields. Wherever there is moving electrons, we will find electricity. These are intrinsic properties of matter and electrons. So consciousness is an intrinsic property of magnetic fields the way gravitational fields are an intrinsic property of matter. After looking at a picture of a simple bacteria with only one chain of magnetic crystals, it's easy to imagine that the nervous system itself that we find not only in human beings and mammals and vertebrate species, that actually evolved out of magnetosomal chains. That as soon as these chains of magnets began to appear in evolutionary history, those species that had them survived at the expense of those that didn't, and those species that were able to develop some kind of tissue around them were better able to survive than those who did not. So it's possible that our nervous systems are the evolutionary end product of these simple chains of magnetic fields. We should remember that every individual is conceived, gestates, goes through pregnancy, is born, and then grows up in the medium of the Earth's magnetic field. Not only that, but our entire evolutionary history happened in the environment, in the context of the Earth's magnetic field, with its geomagnetic storms and quiet periods and reverberation in response to solar flares and things like that. So it offers a way to transmit information. And the odds that human beings or other species found no way to take any evolutionary advantage from this process looks very, very unlikely. What are the odds that there could be a constant varying background environment in which individuals grow up and individual species evolved that offered no evolutionary advantage at all? And if there were an evolutionary advantage, what are the odds that no species would have ever benefited from it? I think the odds are very small. We live in an environment on a planet that's mostly water, and we use water for our survival. We live on a planet that is filled with sunlight, and through our eyes, we've learned to take advantage of it. We have an atmosphere that vibrates in response to events, and we've got ears that take advantage of the sounds that those create for us subjectively. Every single dynamic system that surrounds us is the basis for some kind of evolutionary survival mechanism, and the Earth's magnetic field is no exception. We should remember that every individual is conceived, gestates, goes through pregnancy, is born, and then grows up in the medium of the Earth's magnetic field. Not only that, but our entire evolutionary history happened in the environment, in the context of the Earth's magnetic field, with its geomagnetic storms and quiet periods and reverberation in response to solar flares and things like that. So it offers a way to transmit information. And the odds that human beings or other species found no way to take any evolutionary advantage from this process looks very, very unlikely. What are the odds that there could be a constant varying background environment in which individuals grow up and individual species evolved that offered no evolutionary advantage at all? And if there were an evolutionary advantage, what are the odds that no species would have ever benefited from it? I think the odds are very small. We live in an environment on a planet that's mostly water, and we use water for our survival. We live on a planet that is filled with sunlight, and through our eyes, we've learned to take advantage of it. We have an atmosphere that vibrates in response to events, and we've got ears that take advantage of the sounds that those create for us subjectively. Every single dynamic system that surrounds us is the basis for some kind of evolutionary survival mechanism, and the Earth's magnetic field is no exception. There has been some question over whether or not human beings possess a magnetic sense. That is to say, can we sense magnetic fields? It's well known that lots of other species can, most especially birds, fish, and bacteria. There are lots of others besides. In fact, there have been a few studies that have found people able to respond to magnetic fields. One of them was carried out quite recently, and it demonstrated that at least some individuals were able to feel the difference when they were sitting in a magnetic chamber and the polarity of the chamber switched from north to south. So they would go into the chamber, and the magnetic fields in there were running north at the top of the room and south at the bottom. Then the researchers switched the direction, and the subjects responded. Not all of them, but some of them did. There was another study done, I believe it was in the 1990s, and what happened was that some individuals, just a few, this is a small subject study, but they came into the laboratory in Canada after having taken LSD. And then they sat in a chamber, and there were magnets rotating over the sides of their heads. While they were on LSD and these magnets were rotating, they saw blobs and flashes of light. When they were on LSD and the magnets were not rotating, or the magnets were not present, they did not see the blobs of light. When they came into the laboratory later on and re-experienced the magnetic field rotation Without the LSD, again, they didn't see the blobs of light. The blobs of light that they saw, the phosphine-like phenomena, were only present when they were on LSD and the magnets were rotating. If the magnets were present but not rotating, they got nothing. LSD alone, nothing. So what this implies is that there is some way that the magnetic activity in our brains reaches our conscious or subconscious awareness. Now, because we don't actually have a magnetic sense in the same way that we have a sense to perceive light, a sense to perceive sound, smells, tastes, touch, and so forth, it's quite possible that our magnetic sensitivity plays itself out or manifests through another sense, so that when the geomagnetic field, for example, is in a certain state, we might be more likely to be irritable or calm and relaxed. We might be more likely to have altered state experiences when the geomagnetic field is in a certain state, and so forth. Just because there isn't a uniquely magnetic sense does not mean that there's no way for humans to respond to magnetic fields directly. And now I'm going to come to a subject that will make a lot of scientists roll their eyes, slap their faces with their palms of their hands gently and say, "Oh God, not this again." But in point of fact, worth considering in this video. And that is the question of local versus non-local consciousness. Local means that our consciousnesses are confined entirely and only to our brains. Non-local means other. So is our consciousness local or non-local in terms of the hypothesis that consciousness is an intrinsic property of magnetic fields? And my answer, I have two answers. One of them is yes and no. The other answer is maybe. And here's how it works. If my consciousness is an expression of the activity of the magnetic fields in my brain, then my consciousness is local to me. But magnetic fields don't stop with the cranium or the scalp or the outside of your head. Three words that largely mean the same thing. Rather, my consciousness is composed of magnetic fields, and it can respond to magnetic fields from other sources, including the sun with its solar flares, sunspot activity, and solar storms. It can respond to the Earth's magnetic field. And then let's not forget that there are other people's brains who are also creating consciousness through their magnetic signals operating within their brains, and that the information processing methods used for me to understand, to feel what's happening with my consciousness through the magnetic fields in my brain are also happening in theirs, which means that the language is the same in both cases. And the way that information is encoded in the magnetic fields in both of our brains are the same. That means that it's possible to transmit information from one brain to another. And there have been many studies that have examined brain-to-brain communication. Now, classically, this is known as telepathy. But in point of fact, the studies that have been done have not focused on telepathic experiences. And even a couple of species, including bats, have been found to entrain brain activity between individuals. So what's the mechanism whereby the electrical activity can start to match up, to entrain with the electrical activity in another nearby bat? And the answer is simple. That electrical activity generates corresponding magnetic fields, and the other members of the same species are sensitive to the same information. Therefore, it becomes a very straightforward matter to transmit the information from one brain to another. And this is a good time to point out that Maxwell's equations forbid magnetic shielding. You can create structures out of copper wire, and other magnetic fields that can deflect magnetic fields, but there's no such thing as magnetic shielding. Nothing can stop it, nothing can block it. And there's been some debate in my field over whether or not the human brain can be sensitive to low intensity magnetic signals, with our critics and naysayers saying, no, there's no way this can happen unless it comes through direct current induction. And in order to have current induction, you've got to have very strong magnetic fields, like clinical magnetic brain stimulation devices, such as the ones that we use. In other words, if it isn't strong enough to force current into induction, then it can't have any effect on the brain at all. Well, those arguments were first presented approximately 20 years ago, and they've been overturned as utter and absolute nonsense. Although there was no one who actually pointed the finger at it, it's simply that the pile of conflicting evidence has grown. So I don't want to get too far off into matters of debate and argument, but the fact is, it is possible for information to be exchanged between brains using magnetic fields as the carrier, as the medium. And now we come to the hard problem. At least that's what it's called. Like any other problem, the hard problem becomes easy once you see the solution. So the hard problem is the question of the interface between consciousness and matter. How does the ephemeral and subjective and evidently non-physical experience itself, of consciousness, of awareness, of subjectivity, arise as a result of the physical hardware that constitutes our brain and that supports all of our neural processes? And I'm going to repeat myself a little bit and say that consciousness is an intrinsic property of magnetic fields, and all of the information transmitted through our brain's electrical activity creates magnetic fields that resonate through the brain's system of magnets, magnetosomes, and magnetic fields. And then there is the binding problem, the second aspect of the hard problem. How does all of the activity in our brains and all the activity in various aspects and levels of importance in our consciousness come together to create a unified single experience of consciousness? And the answer, I repeat myself, is that a group of magnetic fields and a group of electrical currents producing magnetic fields as they go along do not create a group of magnetic fields. Rather, they each contribute to a single magnetic field, and because subjectivity is an attribute of that magnetic field, like gravity is an attribute of matter, that experience turns into a single conscious experience. The next conundrum that we want to unravel here is called the dualism problem. So, is consciousness material, or is it spiritual? Is it made of magical kundalini, chi, subtle energy, mana, prana? They actually have a lovely word for it in the Lakota language. I doubt I'm pronouncing it correctly, and my apologies to the Lakota people for this, but shkan taku shkan shkan, which means something that is always in motion. In other words, is consciousness material and understandable through scientific method, or is it magical and can only be understood as an aspect of the will or mind of God? So, if consciousness is an attribute of magnetic fields, is it material or is it somehow non-material? This depends entirely on your definition for the word matter. Now, according to Einstein, matter and energy are two different manifestations of the same thing. We're not going to say that consciousness is a material substance So it's a lot better to work with the definition for the word energy. And I'm not saying that consciousness is energy. So remembering that we're working with energy, at least the energy of the electrical current that runs down the axons in the brain's cells, we need to check in with the definition for the word energy and the definition for the words that it relies on, because all scientific terms have to be definable in terms of other scientific words. So energy is the capacity of a body or a system enabling it to do work. Work is done when the point of application of a force is changed. A force is anything that alters or tends to alter a body or system's state of rest or uniform motion in a straight line, which is to say, inertia. In the language of physics, according to those words with those definitions, magnetism is a force. Gravity is also a force. There are other forces that are at work in atomic physics, but we're not going to go there. If magnetic fields are material, then consciousness is matter, or an expression of matter. If magnetic fields are not regarded as the same thing as matter, then consciousness is immaterial. It depends entirely whether you think that magnetic fields are material or immaterial. And there are going to be a number of people who will watch this and have no training in physics, and they're going to think they know the answer to that question. I encourage such people, please don't write to me. Just get a basic book on the basics of physics and read it first, and then offer your opinion. Because in fact, it's a force, and forces exist as a substrate for energy and matter. The next subject we're going to look at is also going to get a few scientists to roll their eyes, but that's okay with me. And that is the question of the quantum basis for consciousness. And my answer to the question, does consciousness have a quantum mechanical basis, is to not answer it. You see, if consciousness is an intrinsic property of magnetic fields, then whatever the quantum basis for magnetism is, will also be the quantum basis for consciousness. And, while we're on the subject, vice versa. If consciousness is an aspect of magnetic fields, then there isn't going to be a quantum mechanical mechanism that plays out through consciousness in any unique way. It will also occur with all other magnetic phenomena. So, does consciousness have a quantum mechanical basis? My answer is, I don't care. And now a final point that I'd like to make, because I do plan to do a little more writing on this subject. Perhaps if I get the kind of support I need, both money, sweat, tears, no blood, I hope, then perhaps a lot of writing on the subject. But there are several things that are discussed as consciousness, especially in scientific literature, that to me are not consciousness. The self is not consciousness. And you don't need to have a self in order to have a working basis for a consciousness that contributes to the survival of a species or an individual organism. So the self is not consciousness. The self is something that relies on consciousness, but it's a separate mechanism. I have written a book, Sacred Pathways, the Brain's Role in Religious and Mystic Experiences, and there's a good discussion of consciousness and the sense of self in there. The second thing that is not consciousness is mechanisms for mediating state of consciousness. So in one state of consciousness, you're asleep, your head's on the pillow, you're not even dreaming, there is drool rolling out the corner of your mouth, staining your pillow, you're not moving at all, you're completely insensate. That's one state of consciousness. Hopefully, for the sake of your pillow, you don't go there very often, but it happens to everyone sooner or later. Then there's another state of consciousness that you go into if you're crossing the street and you look and you see that there's a large truck moving towards you very quickly, and if you don't act to get out of the way now, you're dead. That's another state of consciousness. There's another state of consciousness that a 17-year-old boy will go into if he sees an attractive, almost naked woman walking down the street. Then there's another state of consciousness that happens as your heart stops beating, your blood stops flowing, you're on a hospital bed, you're 103 years old, and it's finally time to die. That's another state of consciousness. The mechanism of subjective awareness in itself is how we know we're in those states. It is not identical to those states themselves. So that's largely the end of what I have to say, and I thank you all for listening. You can send your comments and criticisms, your fan mail, your gift certificates. Anyway, anything you want to contribute, please do so. My name is Todd Murphy. I am an associate member of the Laurentian University Behavioral Neurosciences program under the direction of Dr. Michael Persinger, who was my mentor for 23 years. I'd also like to add that he approved this message, as the politicians say. He wanted to work on this theory and make a contribution to the eventual publication. Alas, he passed away, but he was planning to create a full mathematical treatment for it. And I would like to see someone who is a better mathematician than I take that on. The details of the strength of the electrical current running down the axons and the strength of the magnetic field variations it can create, together with an analysis of their information-bearing capacity, would be well worth having. So, again, my name is Todd Murphy. That's the end of this lecture, and I thank you all for listening. Bye-bye.